I'm Cezary Siwek. I have around 20 years experience in the RTC space. I'm working as a staff engineer at Stream. We're happy to sponsor the event, help community as well. And I'm currently taking care of our live streaming project and product in general. Trying to make it better. So, two shameless plugs at the beginning. I know the audience is probably not the right to promote our video products, but I actually had a few interesting conversations yesterday, mainly about whether to use like a ready-made platform or have something in the house, and it turned out there is still some interest even in our industry to use ready-made platform, which hides the complexity of video and audio as well. We also leaders in a chat and chat moderation, so this is maybe something that you may be interested in. It's really a cool project. We have really many happy customers. We have few people from the stream here. We have Jose. Daniel works on Unity integrations for gaming, which is also interesting. We have Devin, who works on AI currently, also very cool stuff. So I guess you may approach them and talk about. Okay, and we are hiring. This is the link to our the job board. If you're interested, feel free to have a look. Golang engineers, WebRTC, SDK developers across every subject, basically. Okay, that's enough. Why 4K and 60 FPS and stereo? You may ask. Because customers started asking for it. That's the easy, simple answer. As many of the businesses are customer-driven, we react to what customers need, and this is one of the topics that came out recently. We did have increased number of requests for that. Okay. And why would you need it? In what use cases? It's paid content where you customers, viewers expect good quality, yeah. Also, some customers want to have it separated, have the video separated from other platforms for many reasons. Security is one of them, for example. Also gaming, it's getting quite popular. It's not only for live streaming of someone playing a game, but also using WebRTC within a game. Live music streaming, small concerts. Yeah, we had many actually customers using it for that reason. Live auctions, you probably seen a movement in that. There is, we see the number of auctions being live on the internet is increasing, and WebRTC in particular is good for that because it's real time. You need very fast feedback on what's going on, and the quality is needed to show a product. You probably even saw eBay recently started doing live video for auctions when they basically show a product and try to sell it. Okay. Company events is something that came out recently. Many companies have few offices around the world, They have lots of remote employees. They want to get them together, probably have a large screen somewhere in the office with really good quality video. All hands. Many of those events have some sport-like competition. And so there is some fast movement, so that's why you need high quality, probably high bandwidth and high FPS as well. And why WebRTC? There's plenty of other protocols YouTube never used, or not officially. WebRTC for that, but WebRTC gives very low latency, and we all know it. As I mentioned, auctions, e-learning, all the situations, the audience participation matters. We also been watching the mock movement, and we think it's definitely something that need to look at, and we are watching the space to see what's happening with mock. We will definitely come back to it at some point. And also the easiness to integrate with CDNs, it's also really appealing in that, which is quite hard for WebRTC. Okay, WebRTC is good for, it's adaptive to conditions, to bad network, to low performing devices, etc. So that's another reason. There's a good codec selection. Some protocols don't have it. The other reason why we use WebRTC is because we've got it. Our whole platform is based on SFUs, and it would be really bad to not use it. And it was obvious choice for us. And support for AI. Many AI vendors have AI integration based on WebRTC or something really similar to WebRTC. So that's one other point. So the story started a couple months ago when one of our customers came and asked, "Can you do 4K video?" And we said, okay, we had it in the plan. We knew it's there. It's not complete. I said, okay, we can do it. We need to do a couple of tweaks. It took us a week or two to have a proof of concept. We asked customer to try it, and they said they come back to us. Okay, it works, but it's only 30 FPS. We provide gaming or gaming-like content. We really need 60 FPS. So the 30 FPS was no go for them. Okay, and they also added, yeah, we expect to have 20,000 customers viewing the stream, which, you know, at that point, it started getting serious. So we needed to come back to it. We know it. They also that they need it in stereo, which is also not easy, and I'll come back to it later. Okay, so we started preparations. We had proof of concept. We know it worked. We know we can deliver live streaming at 4K. So the customers, the particular customer is OBS, RTMP, like most of the live streamers do, which means default H.264 and AAC for audio. So typically for the 4K H.264, you need to ingest video on the level of 10 to 12 megabits per second. We also tried lower bit rates, and it even worked. Even playing like Hollywood cinema at 8 megabits. It looked surprisingly good with H.264. So it was kind of baseline for it. Although for the 60 FPS, you need to double that. Yes, that's the basic. So the ingestion has to be on the level of 20 megabits per second, which is also quite significant. So, of course, it all depends on the content of the video. For the conference, like you may probably get away with 10 megabits. If it's a gaming, sports, or something like that, maybe 30 megabits per second may not be even enough. So just bear in mind. This is the ingress part only, so we just need to make sure that the ingress can handle that. The customer can handle that, that has a good internet connection, etc. Okay, the purpose of our ingress, as in many examples, is to receive RTMP, transcode the audio, because RTMP has an AAC, the standard RTMP, not the extended one. Receive the AAC track and transcode it to Opus. We also need to create simulcast, yes, because you cannot just assume that everyone will be able to receive 4K on any device at very high bit rate. So normally we generate 3 tracks, like in a standard 1080p, we generate like 1080p at 4 megabits and 720 at 2 megabits, 2 to 3 megabits, and probably 480 at 1 megabits or close to, or below 1 megabits. And this has been working for a long time. We never had any issues with that. Okay, so we need to decide what layers, what qualities we need to send it to customers. So first of all, which codec is going to be used in the direction to the customers, to the subscribers? What resolutions and what bitrate? So as I mentioned before, we've been using the H.264 for that for a long time, and it's been okay, but we want to explore other possibilities, such as VP9 and AV1, as are probably the best codecs on the market already at the moment. So we kind of selected video that we want to benchmark our what we can get for in specific bit rates, and it's one of the demonstrations of the NVIDIA RTX. Where's my? Yeah, I'll show you a little bit. It's not really. So it's really challenging content, and I probably watched this video hundreds of times. It changed everything when we switched from like a normal movie to that. It's really hard to get a good quality on the streaming on that video. Okay, the standard tool for assessing the quality of the stream is it's a VMAF from Netflix. It seems to be industry standard, and it's open source, and it has a FFmpeg filter for that, which is really handy. So we started assessing it, and the first result we got was this, which is It seems okay for VP8, VP9, and H.264 with the zero latency flag, but AV1 always looked like that. And to be honest, we are not sure why. If you have any suggestions, feel free to reach out to me. There is a special 4K model for assessing the 4K quality. So even if you tweak it, it may look like that. So it's still really bumpy. Also noticed the AV1 assessment. It's really hard. It really depends on how many cores you use. So more cores you use, lower quality you get. And it was no go for us. We were getting completely unexpected results. We couldn't use it on one core because we have to be, very efficient. So we kind of came, and by the way, the AV1 from the 1080p, even 60 FPS, looked really good. So this is the expected result. This is what we would like to get for 4K as well, but it's not that. So we've decided it's probably a little bit too early for AV1 and VP9 for us, at least for now, but I'll also come back to it later. There are a few other issues with that as well. Maybe it's a configuration. Maybe it's us. But and to be honest, if you look at the graph, the H.264 isn't really far from VP8. The VMAF score was always slightly better. However, when we saw the video, we didn't like it. It was for us, it was worse for some reason. Again, maybe it's just our configuration and parameters you can tweak for the encoding part. Also, transcoding for H.264 is really cheap. Although we receive H.264 and we speed out H.264 as well, we need to transcode it. We need to normalize bitrate. So we've noticed that transcoding with transcoding H.264 we can get over 150 FPS like in real time, while for a VP8 it was around 80, and it was single-digit number for VP9 and AV1. But again, it could be due to configuration. So we selected this H.264. Well, we decided to stay with H.264 because we've been using it. We know it works. It's being supported everywhere. It has hardware acceleration, probably in all the platforms. You may ask, why do we want to force a single codec since it's WebRTC? You can always renegotiate if it's needed. The problem is, if you have 20,000 subscribers on WebRTC, you probably don't want to renegotiate the codec. I wouldn't do it even for 1,000 subscribers, to be honest. But I'll also come back to it. So currently we support three layers, three qualities for H.264. Normally, what would you do? Would you, like a normal scaling factor, you would send one 4K60, then 2K60, maybe 1080p 60. But you probably would eliminate lots of potential viewers if you do it. It's too much for many devices and many of networks. So we ended up with this. So the highest layer at 4K60, then 1080p 60 FPS, and 720 at 30 FPS for the lower end devices that really cannot cope with the quality, with the bandwidth. Okay, so the typical scenario for us was that the publisher sends over RTMP. I have to probably add, we also support ingestion via WebRTC, but also come back to it later. So we have RTP, we have the producer, they are our RTP to WebRTC gateway, and a bunch of SFUs. This is, of course, within a single availability zone. If we need another zone, we just create a new zone and we cascade it. And it seems to be working. This seems to be scaling really well for the qualities under 1080p, and also for video. We have customers, and we've tested it with 200,000 subscribers, for example. No issues. And we're also trying to avoid cascading as much as possible. So we started doing the maths for the 20,000 subscribers, having this kind of setup, and for 20,000 subscribers, each one receiving. Of course, this is the worst case scenario. We assume everyone is able to receive 4K. So you probably need around 400 gigabits per second of bandwidth, gigabits. Yeah. Then, like typical EC2 instance is 5 gigabits, but you probably don't want to desaturate it. So let's say the 2.5 gigabits is a safe zone for that. So you probably need around 160 SFUs to handle that many customers. You have to have some headroom for the CPU usage. So this is only considering the bandwidth. If you look at this graph, it means you have to create a link between the ingress and each SFU. And each SFU needs to receive around 35 megabits because you need to send all those 3 layers to each SFU. So the ingress will have to handle over 5 gigabits of data, of bandwidth, and will have to transcode the traffic, which is impossible. So we modified our architecture to have 3 SFUs doing the load balancing only, and then the rest of the SFUs serving the customers. It's working. It scales up to the huge numbers at the moment, so we're good with that. PLIs and keyframes could be problematic because they just do propagate across the SFUs. So we need a way to handle that. So basically, if a browser sees a lost packet and lost video, it sends a PLI, and in most cases we need to or encoder has to regenerate the keyframe. And if you have 20,000 customers, viewers watching it, you have a high chance of receiving lots of those. So what should we do? We can re-encode on each SFU, but it's hard. As you saw, it comes with a huge cost. So we decided not to do it. It's CPU intense. Increases latency, of course, as well. So you can also rate limit PLIs to, I don't know, to reasonable number. So if you do it if you rate limit PLIs to, I don't know, 1 per second, you should be, we should stay at the safe zone. Of course, the downside is that customer may lose video for up to 1 second. Okay, in the case of packet loss, huge packet loss. So So I started playing. I wanted to have my own experience with streaming from a normal device. Oh, I finished time? Do I have more time? Are we okay? Yeah. So I selected I wanted to play with 4K cameras. It turns out they are not ready. The stereo, most of them claims they are stereo. They are not. They're sending 2 channels. And even professional setups struggle with 4K f 60 FPS. We have a customers with the highly expensive gear, and turn out they need to upgrade the equipment to actually support 4K at 60 FPS. The stereo requires SDP munging, and that's the standard for now, which may be problematic. You probably heard about the local host tracking from Facebook. I think Google at some point we're gonna ban the SDP munging. So, but as for now, to enable stereo, you need to munch the SDP. The stereo doesn't work with echo cancellation and noise cancellation. You need to disable that. It works differently across all the devices. So we have a huge matrix of compatibilities and what you need to do on device, and if you need to do that on iOS and that on Android, it's not as easy as it seems. So is WebRTC good for live streaming? From our experience, it's good, but publishers tend to prefer RTMP, and we kind of agree with that. It's easy. You can detect if there is a failures. They can detect. Sometimes with RTC, there is no much visibility. RTMP, SRT give instant feedback. WebRTC needs a little bit more bandwidth to ingest because you need to send multiple layers. It's still good for publishing from a mobile device. What's next? 3 qualities are not enough. We're working on bumping it up to maybe 5. You saw our lowest resolution is 70p R30. You probably need to something between and something lower as well. Offer more codecs. As I mentioned, transcoding is expensive. You will have to probably transcode it and give customers selection of multiple streams with different codecs. It may be cheaper to do transcoding than offering and then spending more money on bandwidth. Yes, bandwidth is also expensive. But for that, we would have to have SVC support, and SVC, as far as I know, it's not fully implemented in GStreamer. As far as I know, it doesn't support temporal and spatial, both layers. We have also WIP, but it's also problematic for now. OBS doesn't support simulcast. There is a PR from Sean, but there is some oppositions against that. I don't know what's happening. That's all for now. Thank you very much.
Thank you, Cezary. I think that we will have time for 1-2 questions. Please raise your hand. Oh, okay.
Oh, okay. Thank you for the presentation. For PLI, so do you just rate limit, or do you cache like frames from last keyframe, or what do you do?
We just rate limit to 1 per second, I think, at the moment, per track, and it's good enough for us. I know, for example, MediaSoup has some transcoding gateways where they can basically regenerate PLIs on each SFU, but we thought it's overkill for us.
Okay, thank you.
This gentleman over there.
So, hello. Yeah, quick question. On the bandwidth estimation, I'd read somewhere that the bandwidth estimation for transport-wide CC doesn't really work over 30 megabits. Did you see that? Did you see that effect, or is that just a piece of gossip?
We haven't noticed that, to be honest. We're still working a lot on bandwidth estimation. We have like kind of dedicated person who work on it almost full time. It's a hard topic. Probably another presentation.
Looking forward to it.
Thanks for the presentation. You mentioned that you simulcast 3 layers. So it looks good for the customers who have very good bandwidth. But what happens when you have a choppy or a low bandwidth? So it really struggles when you have 3 simulcast layers.
Okay, so our lowest layer is 720 30 FPS at 1 megabit. If we detect that's not enough, we have to disable video track and then stay only on audio.
Okay, and then another question. So in case of live streaming, when you have a customer sitting inside an enterprise network, like say 1,000 or 2,000 users sitting behind an enterprise customer, and how does it work when you transfer the RTP stream directing entirely to the enterprise? So a CEO from US and he has an office in India where you have...
We have multiple availability zones. So if we detect that there are people joining from India or from US, we have data centers there, and we cascade the traffic between SFUs, between the zones. And customers, each customer's, well, at least the customers watching it over WebRTC, because we also provide HLS and RTMP out, but customers watching over WebRTC, I mean, each customer has to create its own peer connection and RTP stream.
Okay, thank you.
All right, let's wrap it up with the round of applause.
Thank you.